Friday, 11 p.m. The CTO calls you, furious, screaming that testers accidentally deleted the 50 terabyte production database. The company is losing $10,000 every hour of downtime. And all of this happened because someone misconfigured data cloning. Today, I'll tell you a story that will help you avoid this nightmare. And at the end, you'll make the architectural decision yourself. Ready? So let's describe the situation. A large company. Terabytes of data spinning on EC2 instances with EBS volumes. Every day developers pester us. Give us a copy of production for testing. And here are the requirements the business set. First, we need to clone a lot of data. We're talking terabytes. Second, the test environment must be completely isolated. If a junior breaks something in test, production shouldn't even sneeze. Third, and this is critical, the application needs consistently high I/O. No lags, no performance drops. And fourth, time. The business wants cloning to happen as fast as possible. Sounds quite complicated. 4 different architects proposed 4 different solutions, and only one solution is correct. Let's look at each proposal, for now, without explanations, just facts. First architect says, we take EBS snapshots of production volumes and restore them to instance store volumes in the test environment. Second architect proposes something craftier. We enable EBS Multi-Attach on production volumes, take snapshots, and then attach the same production volumes to test instances. Third architect, snapshots of production. Create new EBS volumes, initialize them, attach to test instances, and only then restore data from snapshots. And the fourth option, snapshots. Enable the fast snapshot restore feature, restore to new EBS volumes and attach to test. 4 options, 4 architects, and only one solution is correct. Now it's your turn. Think. Which option would you choose? A, B, C, or D? You have 15 seconds. Write your answer in the comments right now, before you hear the analysis. I wonder how many of you will guess correctly. Let's analyze the failures first. Option A, instance store. Sounds tempting. Fast local storage, low latency. But here's the catch. Instance store is ephemeral storage. Do you know what that means? It means that when your EC2 instance stops or restarts, all data disappears, as if it never existed. And most importantly, you physically cannot restore an EBS snapshot to instance store. It's like trying to pour gasoline into an electric car. Technically impossible. Option A is a failure. Option B. Oh, this option is a direct path to the hell I mentioned at the beginning. Look at what the architect proposes. Attaching the same production volumes to test instances via multi-attach. Do you understand what this means? A tester runs a data cleanup script, thinking they're working with a copy, and in reality, they're deleting production. Multi-attach is a powerful feature, but it's designed for clusters where simultaneous access is needed, not for environment isolation. This is a complete violation of the main requirement. Option B is absolutely dangerous. Now, option D is tricky. Many of you probably chose it, and I understand why. Fast Snapshot Restore is a really cool AWS feature. It eliminates that lazy loading when data is pulled from S3 on first access. With FSR, the volume is immediately ready to work at full speed. But there are 2 problems. First, money. FSR costs money for every hour of operation in each availability zone. For large data volumes, the bill can be impressive. Second, this isn't the fastest way for cloning. FSR is optimized for scenarios when you need to quickly spin up a volume from a snapshot. Option D works, but it's not optimal for our case. And the winner is option C. Let's break down why exactly this approach is the gold standard. Step 1. We take snapshots of production volumes. It's fast, it's cheap, it doesn't affect production performance. Step 2. We create new EBS volumes, completely separate. Production and test are now 100% isolated. Step 3, and here's the magic. We initialize these volumes before restoring data. What is initialization? It's a process that forces AWS to prepare all data blocks in advance. Instead of pulling data from S3 on every access, we do it once, immediately, completely. Result? When testers start working, they'll have consistently high I/O from the very first second. No drops, no surprises. Green stamp approved. So, what did we learn today? 3 key takeaways. First, Instant Store is not a place for important data. It's volatile and will lose everything when the instance stops. Second, Multi-Attach is not a tool for environment isolation. It's designed for clustering, not cloning. And third, EBS volume initialization is your best friend when you need stable, consistent performance from the very first second. Case closed. Final status, system stable. The correct architectural choice prevents data loss and ensures financial stability. Remember, correct architecture doesn't just save money, it saves your sanity. Write in the comments, did you guess the correct answer? See you in the next video. And remember, choosing correct architecture means peaceful sleep at night.